Okay, welcome to another Java Masterclass. Today in our class, we'll be discussing about Java Lesson 4, which stands for Functional and Concurrence. This will be your agenda. First, we're going to talk about immutable objects. Second, annotations. Third one, and we are going to focus on this, is the lambda expressions. Just give me a second, I will have my pointer. Okay. And fourth, functional interface. Third and fourth are relative, so we'll be discussing these 2 points. Concurrency and threads will be your number 5. Exception handling, exercise tips, and general info, and a question time. So let's begin. First of all, we're going to talk about immutable objects. So immutable objects are objects whose state cannot change after the construction. So for example, the string class. Is it different from primitive types? You can modify strings? And the answer is yes. Strings are different from primitive types, and strings are also possible to modify in some way. Let's check an example. So here I have an example. And in this example, I have created a string object. Remember, objects are on heap and primitive types are on stack, as you see on the video. So first of all, I create string 1 with the hi string, second one with Joseph name, which is my name, and third one a empty string. So by default, this has the value of null because it have not been initialized. And then I have defined a primitive type int, which is my age, 21. And then I modify the age or the primitive type int. So at runtime, at this point, our value will be 22, right? And then I get into the string and I use the concat statement or method. So the concat method, it's for put together 2 strings. So I will put together the hi string or the string 1 and the string 2, which stands for Joseph. And then okay, so this will be hi Joseph. And I print the result. So let's see how it looks. So, okay. Sorry, I just missed that. Okay, so as you can see, the result is 22. I want to zoom it in. 22 and high, but high is not what we expect, right? Why is that? We modify the string. I mean, we modify the string 1 and concat the string 2. Why that doesn't reflect on the print line? I mean, the 22 is reflected because it's age now it's 22 and it prints 22, but the second print prints high, and that's because they're immutable objects. So remember I told you that immutable objects are objects that cannot be changed after their construction. So how we modify a immutable object? We can't. We construct another object. So as you can see here in the, we're gonna take some string Java class. So in here, I will refer to the 8th version, and I will search for the method concat. So in here, we have the method concat, and it says that concats the specific string to the end of the string. And that's it, right? So we like chars.concat as it cares. But we notice something. This is the like the structure of the function. So it receives a string and it's applied to a string, but it returns a string. So as strings are immutable objects, you cannot modify them, but you can create new ones with the modifications you want. So for example, in here, the string 1 will be the same, hi. The string 2 will be also just that, like the same. But this operation will return you a new string. So let's see how it looks. So my third string will be equals to the result of the modification or the instance of the modification of the immutable objects. And then I will print my new string. So I will need to, again, compile. We don't have any problems. And then I will run it. So that's it. Hi, Joseph. It works, right? So remember, when you're using strings, you need to know that strings are immutable objects. So you cannot just call from a method to modify the string. You need to call a method to create a modification, and then the result you will need to store the result in another object of that type, which in this case is a string. So that's all about immutable objects. Strings are objects that you will be using often in your course. So let's keep going. Okay. So far, we know that they are different from primitive types because they are stored in the heap, and primitive types are stored in the stack. And you know that primitive types, you can make some operations through primitive types, and you can make some operations and you can apply methods and things like that with immutable objects or objects that have like a class. Modified strings, you cannot modify strings, but you could create a new modified string. Like with the example, it's with my string 2 and my string 1, and we concat those, and we create a new string called string 3. Okay, so let's keep going. Annotations. So as you see, like in my previous example, I have these things right here, which stands for comments. And this is useful for us. I mean, when you're programming and you want to know what you're doing, so for example here, it helps us with the flow of the program. We create some comments to know what's going on in the program. And that's for us, humans. So Java has a type of comment, or it calls annotation, for the compiler. So it tells some additional information to the compiler. We have used, or we're going to use in this course, some annotations. And some annotations are override, which stands when you want to override a method. Suppress warnings. So for example, you are using some unchecked things inside your program, like you haven't declared implicitly the conversion or something like that. And functional interface, which we are gonna talk about later. So I have an example here about annotations. And let's skip this. Okay, annotations. In this annotation example, I have, let me search for it. I have like a lot of examples. Okay, right here. So, okay. So we have this example, and it's a really simple example. Like I want you to know in which cases you can use the annotations. Annotations, they are not often used when you're using like a text editor. In this example, I'm using Sublime. But if you are using an IDE, like for example, IntelliJetty or NetBeans or Eclipse, it will be like really common to use annotations. So in this case, I have a class called annotations, I have my main method, and I have created a linked list. So as you can see, I have declared that this linked list will have objects of type string. But when I create a new linked list, I didn't mention that again. So this is valid in Java, as we've seen in previous lesson. So will be a valid statement. And but okay, let me do not use that. But it's called an unchecked warning. So it is unchecked because the compiler says, okay, I accept this, like I accept this statement, but I want to make sure you are really want to make this. Like for example, you really want or you mean to, you're using the string. So you're using like you're gonna store strings. Okay, so second one, declaring inside. Okay, so you can also declare like multiple class in a file, but the first class, or you have to have one class with the public with the word public. I mean, it needs to be public. So okay, we have declared another class called A, and it has some method called some method, and it prints I am method of A. Then I create a class B, which is extending from A, so it inherits the sum method um, object. So it calls we override the sum method, and we print I am override method of A. Okay. Also, we have provide and override annotation. So if I comment this thing, it will not have any troubles. And we use annotation override to avoid misspelling methods that we want to override. So let's take an example. Okay. So far I have commented all the annotation. So we don't have annotations right now. So let's compile the program. Okay. So as you see, it says annotation Java used to uncheck or unsafe operations. Note, recompile with xlin to uncheck for details. So this is basically because of this. And let's suppress that warning. So again, let's compile. And it compiles okay. So as you can see, we have suppressed the unsafe check operation, which stands for the unplaced string here. And let's see if it works, the overriding method. So in this case, I am creating an object of type B, and inside of it, I will store an object of type B. So it will call B dot something. So because we have override some method, the or expected print line will be I am an override method of A. So let's see if it works. And it works. I am override method of E. But what happened if I make this? And let's compile again. Everything is okay, right? And then we run it. And I am a method of A. So what happened? It happens that, okay, B stands from A. So it has inherits the sum method function. And then we place B, sum method. And we play some method, but we have like mistyped the m or the name of the function. So it doesn't call for this method, which I want to override, but it calls for the method, for the original method. But what happens if I type in or I place and override annotation? And this is the way the annotation is useful. Let's check. Okay, so we compile it, and then it gives me an error and says method do not override from implemented method from super user, because it doesn't exist a method called some method with the uh, little case m, but because it's uppercase, right? So the compilers tell me that I am mistyping this method, and I am not overriding any method. So it helps me, right? Because if I place it the way it needs to be, then it tells me everything is okay. So override methods helps me to know if I am overriding a method or not. And it helps me like a lot. And suppress warnings, which checks for unchecked warnings. And that's how we use annotations. As you may know, everything have tell me about my errors and some annotations in compile time, not in runtime, because annotations are for compilers. So at compile time. So that's the method of that's annotations. We're going to talk about now lambda expressions. So in this course, I have seen like a lot of questions about lambda expressions, and lambda expressions are like really cool. You could see like the videos in the lesson. We're gonna recap those videos here. So basically, lambda expressions are anonymous functions. It helps you to make your code looks better. You make less code with lambda expression. So the structure of a lambda expression, it's this way. You have some parameters and you have some behavior. Also, you have to use this called arrow token. So our arrow token will be our identifier for lambda expression. So inside here, our parameters could be empty or not empty. And our body could have like a lot of statements or could have just one statement. So let's see an example. Also, you have to notice that Java 8 is the first Java version which supports lambda expressions. So in this here, I took the original example from the videos, and I will explain it, and then I will show you another example about lambda expression. So the video inside ADX, it tells you about how does the lambda expression, or how lambda will create, I mean, the function that lambda makes was doing in Java versions earlier than or older than Java 8. So it, it tells you that there is an old way to do lambda functions, and that's here. You first of all, you have declared a here inside. I have create a instance for my project. So my project for my class, I mean. So my class, it's called lambda expressions, and here you can see class lambda expression. So I have made an instance of my class, and this is a good practice to, if you have like different things inside, objects inside your class, and you want to make reference to methods that are inside your class with a new instance, you can create it by a new instance of your class right here. So inside my class, I have a method called do it in the old way, which stands for the old way to do it in lambda way, and do it the lambda way, which is the new way. I mean, I have new way. Okay, so first of all, let's take a look about do it in the old way. So do it in the old way, you right here, you have a definition for a functional interface. So I want to talk about like really quick about functional interface because we're gonna like take a look more deeper inside functional interface. But basically, a functional interface, it is an interface with one method and with one abstract method. So right here, you can see. Also, check this. It is about we are using an annotation functional interface. So this helps you because if we define like another method abstract, like void method, this will give you an error. And why? Because you have the annotation right here. And the annotation right here is telling the compiler that this interface should only have one method. So you know how annotation works because of the earlier explanation. And then in here, we are creating a new like interface, new instance of that interface. And inside of it, we are overriding the do something method. I mean, this method right here, do something method, it's being override inside here. So this is called like, I don't remember how it's called. Secret, like this is an anonymous class. I mean, have forgot the name. So, but basically it is that inside here we override the method of my my function. So like it is a lot of code, right? And then I have my object implementation to be placed. So inside my like how did I call that later? Secret class or like anonymous class. We call for the method inside of it, which is overridden from the method of my functional interface. So as you can see, you need to make an like instance of that interface, and you have to override the method existing inside the interface, which is a lot of code, right? But it works, right? But now we have lambda expression. So let's see how it works with lambda expression. So doing in the lambda way, we also create a instance for functional interface. But in this case, we make an anonymous method right here. So this is my lambda expression. So lambda tells you that you are going to have a method that has or receives an string. And inside that method, you're going to print that string. Simple, right? So this code or this line of code makes the same implementation or stands for the same output for this code. So, okay, let's see. This code is like 1, 2, 3 lines of code, right? And you can make 3 lines of code be one with lambda functions. And that's pretty cool, right? And it is simple because we do not have to make an override of some kind of method and that sort of things, but we only place a anonymous function that match with the function given. So for example, in this case, do something expects a string and doesn't expect a return. So in this case, we made our lambda function expecting a string. And if, as you can see, even doesn't have the identifier. I mean, that's like a really cool type of lambda function because we here need to have some identifier for the override function, which needs to be like the same name of that function. But in here, we don't need to have an identifier of name. We just make our lambda function. And then we call for our object, and we call the do something method. And the do something method is because we are getting the method inside the inside the functional interface. So this code does the same as all this code, but in a better way. I mean, uh, looks pretty nice this way than do it like in this way. Okay, so also using lambda functions and functional interface, you could have a function like being a parameter or an argument inside a function call. And that's really, really cool because, I mean, so far you are using arguments or parameters of type of a class or a type of an primitive type. So for example, I could make a method, a public method, public void method, and I could call it with an primitive type of type A and a class of type string, of class string S, and I could make some code here. But what happened if I want to like use multiple functions right here? I will need like some if then else case. So for example, if A is greater than 0, then call to method 1, and else if E is less than 0, then call method 2, and so on, right? But wouldn't it be great that you have you didn't have to code this thing and just call a method like let's create a method like make or run this method with the input you have and with the method you want, like some function function or method. Okay, so that would be pretty cool because I could erase all this line of code and I could have like in here the function that I want, because I mean you maybe this is like a really silly example, but have a function and I could here have like this will be like a method and call function, right? And here I called for the function, and that will be really cool. And with a lambda expression, you could achieve that. And let's see how you can achieve that. I mean, first of all, you need to know that there is an order inside functions or function programming. So you can have like a high order function and a lower order function. So first of all, let's create a high order function, which will be this one. And as a parameter, and take a look right here, it accepts functional interface. And that's really, really cool because, I mean, you as a parameter are receiving a functional interface. And that functional interface will determine the behavior you are using. So in this example, I have created a behavior which stands for print line. So this is the behavior for the print line function, for the original print line function. So I have, so print line function has some print and a void, which it receives like this like print line receives string and returns nothing. It has not returned, so it's a void. So so far, this definition for this method matches with the abstract method we have declared in the functional interface, right? You could take a look about the implementation of println, and you will know that um, it calls for a method print that only has like these things. Okay, so that will be our behavior. And then we call the high order method and we pass on the behavior. And then inside that function, we call this something method, which stands for the println method. And the result will be the print of high order function. So let's see how it looks. So all weight, lambda weight, high order function, high order function. And that's why, because we call for the all weight, then we call for the lambda weight. And then inside the lambda weight, we also call the function of high order, but with another behavior. So as you see, we have called the behavior with inside in this line of code, we have called with the behavior of print line. And inside this bunch of code, we have called the high order function with our lambda anonymous function, which stands for our behavior, which will be a print line. And it's called right here, right? So, and again, it prints high order function, and then we call again the high order function with a different behavior. Notice that the behaviors needs to have the same structure as the method inside the functional interface, which receives a string and has not return value. Okay, so that's it with this example. Let's see another example of lambda expression. So inside this other example, I have placed different functional interface, and this will help you to achieve your exercise. You're gonna use lambda expression inside your exercise. You're gonna make a calculator or something like that, I remember. So let's take a look of this code. So first of all, I have created two different functional interface. First one is no params. So this functional interface doesn't receive any parameters, as you see, and returns a string. That this will be my abstract method, right? Then I have declared a math operation interface. So it has a method called operate and stands for one argument of type int, which is a primitive type, and a second one of also a primitive type int. So that's all with functional interface. Then let's see about the class. And the class is called another lambda example. And then inside we have create instance of the functional interface with the function that we want to make. So for example, in the first one, we have create a whole secret code. So notice that all these functions are our behavior. So remember, we have different behaviors and we can achieve different behaviors using lambda expressions. So with no params is expecting a method that gets no parameters and returns a string. So in this case, I have declared with this lambda expression. So this lambda expression, I'm gonna make it like bigger code. So this lambda expression tells you that you're not receiving any parameters, as you can see, and then the arrow token, and inside it will return a string called this is the secret code. And okay, so our behavior will be like every time we call this, it will stand for this is the secret code. Okay, second one is the math operation. So the math operation will receive a two primitive types of type int and this will call addition, and it will receive the two arguments. Also, and this is really cool inside lambda expressions. You could place an identifier of the type you are expecting. Like you can place int here and int right here, or you can not, and everything will be okay. So in here, it will return the x plus y operation, which is addition operation. Then with multiplication, remember also I have made this to you to notice that inside the previous lambda definitions, we have defined using the keys, and also we have defined with no parameters, with parameters, with keys, and also with no keys, like right here. With the multiplication function. And so we take x multiply y, and we also have the subtract function. Also notice that, and this is really cool, a math operation needs you to return an integer, but you can avoid the return inside lambda function when you are operating. So for example, I really don't have any return statement, but the return statement is implicit right here in this statement, but I make it explicit in the other ones, like return x plus y, x plus y, um, inside the subtraction addition on the secret code. Okay, also I have division. So remember, you could place like a lot of lines of code inside your lambda expression. This is how. So first of all, I place this because division by zero, it's not defined. So it will give you an error. So I am trying to avoid errors inside my code. So first of all, because I'm going to use x division y, I need to know if y is different from zero. So if it's different from zero, I will make, or I will return the division. And in this example, if y is zero, I will return a zero. Um, this is for this example because we know that division by zero is not defined. So let's keep with that. And also, I have created a function of high order. And I have created a function of high order to help you see how you can use like high order functions to work with low level functions. So this high level function receives the parameter of type int, which stands for x and y, and receives a behavior which will be our operation. So it says return operation dot operate with dot numbers. So this is really cool because we are using a one method or function to receive different parameters and to receive different behaviors. So if you want to make an addition, you will call x1, or like 1 plus 1 will be 1, 1, and your additional behavior. And this code will be supported by every math operation behavior. So let's see an example. First of all, I print my secret code dot message. So it will print, this is the secret code. Then I am making an addition dot operate 21 plus 1. So it will be 30. And then I am making some examples of simple calc. So you're making like a definition for a calculator to work in every way. And this is really cool. So with our simple calc, we can make additional, division, multiplication, and subtraction. And this is like how you use an expression. So let's take a look. I will compile it. Well, I have already compiled it. So another expression example. Okay, so first of all, as you notice, it calls for this is the secret code. Second one, the addition of 3 plus 3. Oh, 3 plus 3? No. Okay, so yeah. So first one is the message from the secret code. Second one is the addition operation for 21 plus 1. Second one is addition of 3 plus 3, and so on. So as you see, the division right here in this place um, is the division by 0. But because of code of our code, the result is 0. And that's how the lambda functions works. So that's all with lambda functions. Hope it helps you to understand how you can use lambda functions. I mean, the things you need to know with lambda, you first of all need a functional interface. You need to have your lambda structure needs to have like the structure inside the abstract method, and then you have to place the functionality of your function of your lambda function inside the braces or the code you want to make inside your lambda function. So let's see if I had an example. I think that's all for lambda expressions. I have another example using lambda expression, but it's for functional interface. So let's keep moving on our presentation. We don't have like a lot of time. So functional interface. So functional interface, as we talk later, we use them to make use of one abstract method. And functional interface are part of Streams API, which are developed for Java 8. And that's really cool because we use something called stream, and then that stream serialize or information, place them in an intermediate operation, and then place them in a final operation. So maybe you want to sort some like list. First of all, you stream it, you serialize the list. Second one, you apply the filter method with the functional interface, and then you apply a condition for that filtering. So for example, you only want to print all odd numbers. You could first stream your linked list or something like that. And then you filter those values, and then you have the condition of odd numbers to print. So some functional interface inside Java 8, it is list, predicate, comparator, and so on. So there are like tons of functional interface inside Java that you could use. Now, so let's see an example about functional interface. So for functional interface, I have this example. And inside this example, first of all, I am creating a list of integers. So this is like a really cool way to make a list with default values. So you could array that as list, and you place it values, and it will create you a list with all those values. So I have two lists. I have an integer list and a string list with names and with numbers. So first of all, I want to display every like every name inside my list. So I'm using list dot for each. And notice that so far we have seen our lambda expression, right? So what we're doing right here is that we are overriding an functional interface. So let's see how those lists stands for each. So for each is an iterable method. So we will search it right here. So let's search it. List Java API. Okay, so I have my list right here. I will search for 8 version, and like in here at the end, it tells you that for each is a method inherits from iterable. So let's see how it looks for each. So for each could be applied to a list. So we are making that here. Names is a list, and for each is a okay. Just wait. I having okay. So let's keep going. So as we are again. So okay. So let's let's retake the example. So as you can see, for each has been applied to a list. So we are okay. For each is a inherit method from iterable. So we have names, which is a list, and we are using for each. But in here, we are placing a lambda function, right? So for each says that it receives a consumer. So what is a consumer? Let's see. So as you first notice, a consumer is a functional interface. And this is really cool, right? Because for each will be a higher method. So a higher method that will receive a behavior, and we are placing our behavior right here. And that's really cool because I mean, for each has a consumer, and this consumer has a only one method, and this method is accept. So accept receives as parameters a one object of type T. So we are using generics. So it accepts any object of any type, and it doesn't return anything. So it's a void. So the same we are making right here. We are receiving one object of, in this case, type string, and we are not returning anything. We're just printing. And that's really cool because I mean, we have used a iterable method, and inside though that iterable method tells me that it's expecting to have a consumer, which is a functional interface. But we are telling that our functional interface behavior will be this one, which stands for printing the names. And this is really cool. Okay, second one, let's display even numbers. So inside even numbers, as you can see, we again use the for each method because we are having a number of lists. We are accepting just one parameter, and that parameter is of type integer. Then we are checking if that integer is a even number, and we are printing that number. And as you can see, we are compiling. I mean, we are achieving what is being asked for us to do. I mean, for each is asking that you need to have a functional interface. In this case, a how does that was called? I mean, a consumer, and that consumer needs to have a method called accept, or a method or a behavior that accepts some type and returns void. So that's what we're doing right here. I mean, it doesn't tell you that you cannot have any implementation inside of the behavior, but the only rule that you're giving it is that, first of all, you need to have a parameter of some type, and second one, this behavior doesn't need to return any value. So as you know, system.println is not returning anything. It's just showing the result inside the console. So we're okay with that. I mean, we're right. Okay. Second, I'm gonna use a string to you to notice that you can serialize like data. And for example, let's see. I want to print names with which stands for or with start with the A letter. So I just want to print names that start with A. So I could do it like in this way, but inside this, I need to have like a lot of logic and a lot of code. Therefore, I'm gonna use a thing called stream. So first of all, I have my names to be serialized. So stream creates a new like flow of data that I can use. Second one, I'm gonna filter it. So filter it is another another functional another method that expects another functional interface. In this case, a predicate. So filter expects a predicate. And what is a predicate? Let's see how it looks like predicate. So I'm gonna also place filter with for the stream Java API. So let me okay streams Java, and we'll call for filter. Okay, so filter right here is a method that it's applied to a stream object, which we are doing right here. We have make a string object, and that string object is called with filter method, and that filter method expects a predicate. And let's see what is a predicate. So, surprise, we have a functional interface right here in predicate. So if we have a functional interface, that means we can use lambda expressions. And let's see what method we need to override. So this tells me this is a functional interface whose functional method is test. So what's expecting test? Test expects a type of value and returns a boolean. And it says evaluates the predicate on the given argument. So returns true if the input argument matched the predicate, otherwise false. Okay, so let's see. Here we are receiving as parameter an object. So we are okay with that. And second one, we are making name dot starts with A. So starts with A is a method applied to a string object, and this method returns us a boolean if the name starts with A. So as you can see, we have our input of type method, and then we have a receiver. I mean, we have a or lambda code, and inside our lambda or our lambda code, we are returning implicit return, as you see, a new boolean value, and then all the filter that data, it will be collected inside collections to list. So I'm creating a new list of names that start with A, and that's really cool because I mean we didn't have to like code a for statement or a while statement or an if then statement inside this line of codes to create a new list with just the names of that start with A, and that's like the purpose of functional programming, and it also looks really cool and nice. And then we are again using for each, and we are printing the names. So let's take an example. So let's see how those that looks. So Java functional interface, functional example, and boom. Okay, so first of all, we have print Andrea, Lucia, Andy, Brand, John, Joseph, all the names. And the second one, we have print the odd numbers, which is 2, 4, 6, 8, 10. And last one, we have print just the names that start with A, which stands for Andrea and Andy, as you can see right here. So everything is okay. That will be the example for functional interface. So remember, functional interface helps you to achieve the use of lambda expressions. It also helps you to define behaviors, and they only have one abstract method. So let's keep going with our presentation. And functional interface, okay. So concurrency and threads. So this is like a extensive topic, but I wanted to focus just only in the lambda expressions. But I will have an example for this. So threads in concurrence stands for multiple process or something called multi-threading. So it's good to know that a process could have multiple threads. I mean, a process have multiple like instances of your program, but a thread has only one process. And what's a process? A process stands so for when a process starts, it's reserves memory space and is in charge of the scheduling of your different programs. I mean, they are execute at the same time, but a process needs to schedule the available resources for those processes. Okay, so concurrency happens when you have like different threads. So I have a thread one and a thread two, and they want to achieve for a common resources. So what happened if I have like bill account? So in my bill account, I will have like, for example, $1, and process one needs to grab that dollar, and process two needs to also grab that dollar. So for example, if process one gets first, it will see, okay, I have $1, and then I will decrement that value to 0, but at the same time, the other process sees the my account, and for the other process, it also has $1, and then it decrements the value, and the last decrementation result will be placed. So I have achieved, um, I have decrement $2, and my bill account, it tells me that I have $0. And I mean, for us it's okay, but for the market, isn't it okay? So I mean, you are like multiplying your money because you had previously $1 and you pay something with $1 again, and at the same time you pay for another one, and it only costs you $1 because the concurrency problems. But we can like correct that achieving shared data. I mean, locks. So a lock will be something that, I mean, one process gets or achieves the to get one resource, and it locks the other process. I mean, the other process cannot achieve that that resource until the last process or the last thread um, finish the use of that resource. So this will be like a really quick example because it's like um, a long definition of threads and that so on. And I want to make you know that you also can use lambda expression for threads, and that's another really cool thing because I mean um, that's the way you make threads with lambda expressions. And let's get started. Okay, so first of all, I create a new thread, and second one, a thread class, as you've seen, it receives a runnable implementation. So let's see the 8. Okay, so let's see our constructor. So inside our constructor, we have thread, and we have runnable. So this is a runnable interface. And surprise again, it's a functional interface. So you can make this. First of all, I want to create like different behaviors for threads, and I will have 3 threads. And that's how, I mean, remember, you have to have a type of that functional interface. So my type will be R1. And inside my functional interface, I have a method called run, as you see, and it's void and it doesn't have any arguments. So this is equals to this lambda function. So in this lambda function, I have a method called, I have this method which will be or equal method for the run method. So inside of it, I have a print line with R1 start. Then I have a thread slip, which this slips the thread for this time. This time is in milliseconds, so this will be a 2 seconds. And then it prints the end of the thread. Also, we're gonna talk about this, like try catch things, and every thread is implemented that way with different times. And then I start the thread in that way. So let's see an example. So thread, that example, and see. Okay, and now it ends. So first of all, it starts R1, then start R3, then start R2. But when we start at R2, the time for R3 has timeout, and then the time for R2 timeouts, and it ends R2. But at the very end, the time of R1 ends, and that's why, because R1 has 2 seconds, R2 has 1 second, and R3 has just the half of the second. So the first to stop will be R3. So that's how you manage to have like threads using functional interface and lambda expressions. Okay, let's keep going. And then we're going to talk about exception handling. So exception handling helps you to check or detect some errors. So for example, checked exceptions, you could detect it at compile time. So for example, as you remember, if we mistype something, or here you can use like annotations to detect that, also that errors. Unchecked exceptions occurs at runtime. So for example, inside or example of our calculator, if I make a division by 0, the compiler doesn't know if I am making a division by 0, but the Java virtual machine at runtime knows about that error and crashes. And we have like some special errors. The common cause of that special errors are logical errors. You can have multiple exceptions, and we're going to talk about that later. You have you could achieve to have a way to recover for errors or exceptions that occurs at runtime, but maybe it occurs like division by 0, and maybe you have like a index out of bounds, which happens like a lot of time, and you want to recover from the index out of bounds and from the other exception. You could do so by using multiple exceptions and handling. And the exception handling helps you to manage errors at runtime, and that's really cool. So let's see an example of what I'm talking about. So I have a source. Maybe I have here. Okay, maybe I don't have like an example. Just give me 1 second. I think I have it. So if I don't find it, it is okay because we are gonna. Yes, okay. We are like out of time, but okay. I will explain that with this thing. I mean, in the videos, I like really explain it, but as you can see, this right here, this code, it could have an exception of thread sleep because maybe the thread is not more available, or maybe the thread hasn't started yet, and it get confused and everything like that. If an exception occurs at this time, it will give you an error inside your compiler or inside your code. So to handle that exception, we catch the exception, and then we print the exception. I mean, in this case, we're printing the exception. But in another case, I mean, you can like rerun the thread or something like that. Um, and that's basically try catch. I mean, the ability of recover exceptions or errors inside runtime or at compile time, and that's pretty cool. So okay, let's keep going. And I mean, we have our final or final topic. So inside our final topic, we're going to talk about exercise tips and general info. So inside tips, recommend you to use Lambda implementations like a lot because they are really cool. I recommend you also to use the stream library because, as you can see, you can make more with less. And remember the thread implementation. I mean, remember that you can use a runnable functional interface, and that runnable functional interface, you could create a run method for a thread, and you can then execute it. So finally, inside this lesson, you will have 3 exercises. An exercise for Lambda expression, which is a quiz of Lambda concepts, in student organization, which stands for a Lambda functional interface practice. You will see how to organize like some students using a Lambda function, and a movie theater. And this will be a threads practice. So you could practice some thread concurrency and threads life cycle. So that's it. Um, we have finished our masterclass Java session, and I will be here around like for some time, so you can place your questions. I'm gonna see if you have any questions like in this. I can check it right here. So I mean, you can use the chat to send message or to ask for questions. I think in this case doesn't have like you don't have any questions. Um, so that's okay. I think you have learned everything, or you are okay with the lesson. Okay, that's good for me. Also, you have some questions, you can ask them in the forum. I will be there to respond to that. Um, it was nice to meet you. Um, Thank you. That's all. See you in another masterclass lesson.